Hey, welcome to Midverse Education. Today, we're looking at cubed and other roots. So, let's go. Alright, we have the cubed root of 8, which, by the way, you may just be like, what is that? I've seen square roots before, but why is there a 3 up there? Alright, anyways, it's called a cubed root. Alright, all it's saying is that what number times itself 3 times is 8. Not times 3, but what number times that same number again is 8. And think for a little bit about this, alright, and try to figure this out. And there's multiple strategies that you can use. This one you may be able to just like, oh, hey, yeah, I think I know that. Alright, but if you're not sure, what you can do is just divide the number and then see if that helps you figure it out. Like this one here, it's an 8, it's even number, I probably cut it in half to 4. So I have 2 times 4 is 8. Can I split that 4 up at all? Oh yeah, 4 goes into 2 times 2 is 4, so I have 2 times 2 is 8. Or so 2 times 2 times 2 is 8. That works. Okay? Or you can just do trial and error. So I start off at 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, and so on. Alright, let's try another one out. Oh, by the way, the cube root of 8 is 2. That's how you say it. Alright, let's go to the next one now. So the cube root of 125. Ooh, a little more tricky here. Alright, anyways, what number times the same number times the same number is 125. My clue for this one here when I saw this was, hey, this ends in a 5. I'm going to divide that by 5 and see, do I have a number that gives me 5 times itself? And I actually do. So sometimes you can get clues from the number itself. Okay? Again, this has a little 3 in front of it. So I'm looking for numbers that are multiplying by itself 3 times to get the number. If there's a 4 or a 5 or a 6, then that's about numbers that are multiplied by itself to get the number. Okay? So again, how I say this is the cube root of 125 is 5. All that's saying is that 5 times itself 3 times is 125. By the way, these are inverse operations of exponents. Alright? So 2 to the 3rd power is 8. What do you mean by inverse operation? Well, multiplying and dividing are inverse operations. Adding and subtracting are inverse operations. Sometimes people say they're opposite operations. Okay? So 2 to the 3rd power is 8. You can also say that 8, the cube root of 8 is 2. Same thing with 5 to the 3rd power, it's 125. And then the cube root of 125 is 5. So, alright, but these are nice to work with. But what if you have something that's not so nice to work with? Like the cube root of 3,000. I have no idea what this is going to be. Well, my first thing I'm going to do is I'm going to factor that apart. Just like I did with the 8, I cut it in half and then figured out from there. And the 125, I divided by 5. I'm going to do the same thing here. Alright, this time it's just a bigger scale. So I know 3 times 1,000 is 3,000. So let's start there. Why not? And usually I try to keep my prime factors, like that 3, off to the left side. A prime factor is one I just can't factor anymore. It just has a 1 and itself that goes into it. Alright, and I keep my composite numbers off to the right side. This is a strategy that I use to keep myself organized as I'm factoring these numbers. Okay? Look at the cube root of 3 times, and it broke 1,000 into 10 times 100. Alright, and again, I keep my prime factors to the left, but 10 is not a prime number. That's a composite number. So I'm going to split that 10 up into 2 times 5. And again, I'm working myself from left to right. So now I have 3 times 2 times 5, which are prime factors. But then I'll get to that 100 now. I'll split that 100 into 10 times 10 because I know that works nicely. And then I just did 10 right above there. I'm just going to split up both those 10s right away to 2 times 5 and 2 times 5. Okay? So now I have the cube root of, take a deep breath, 3 times 2 times 5 times 2 times 5 times 2 times 5. Whew! And by the way, if you put that in a calculator, it's equivalent to the cube root of 3,000. Wow, crazy. All right. Anyways, now we have prime factors. And you might remember doing this like a long time ago. Maybe not, but this is where it was heading. And it still heads more places down the road. Just throw that out there. Anyways, what we're doing now is we're looking for triples. Well, this looks just like what we're doing with the square roots. Yes, with the square roots, we were doing pairs because it was a square root. Now we're looking at a cubed root. There's a 3 in there. So looking for triples. And it's like if you had a 4th root or a 5th root or a 6th root, you'd be looking for groups of that many. Okay? And then we're going to separate those into their own little parts of this expression. So in here, I have 2, 2, and 2, and I have a 5 and a 5 and a 5. There's my triples, my groups of 3. 3 2s, 3 5s. I'm going to rewrite this just to make sure I don't mess anything up. Because sometimes you get really big numbers and you have like numbers that aren't part of the triples in between them and you just might lose them. So it's just kind of nice to rewrite it all out. Okay? So now I can separate this. I can pull this apart. And because we're multiplying, I can pull them and make their own little cube roots as long as I'm still multiplying. Okay? I can't pull it out and start adding or subtracting. I have to still be multiplying. So I have the cube root of 3, which is that prime factor that didn't have any other ones to combine with. And I have the cube root of 2 times 2 times 2 times the cube root of 5 times 5 times 5. Now I'm going to multiply to kind of make this a little nicer to see. So I have a cube root of 3 times the cube root of 8 times the cube root of 125. Okay. Now I'm going to take the cube roots. I just did these same ones on that last slide. So it shouldn't be too crazy to be like, hey, the cube root of 3 times 2 times 5, because the cube root of 8 is 2, and the cube root of 125 is 5. All right. And yes, I know most of my students have, once they made their groups, they just pull that number down into this line here. I wouldn't start going there unless you're super comfortable with what you're doing. Even then, you still might make mistakes, so just kind of heads up. You can always check your work at the end by typing into your calculator and see if you get the same thing that you get with the original expression, because you're trying. These are all equivalent expressions. Okay, so just heads up on that. But what we're doing now, why we don't just put that original square root of 3,000 into a calculator right then, is because it's an irrational number and it looks really ugly and gross. Where what we're doing right now is to make it a lot cleaner and a lot nicer to work with, especially as you get into algebra and beyond. Okay, there's a reason for doing all these steps to make this into a different form or a different equivalent expression. Okay, so I'm gonna do 2 times 5 just kind of simplify that part, and then right here I could be done, but I don't know if that 10 is being multiplied by 3 or if it's being multiplied by the cube root of 3. Well, I know, but if someone else read this, they wouldn't know. So the standard way of rewriting this is you put your multiplying in the front. So we have 10 times the cube root of 3. Okay? And again, I don't put the multiplication there because when you don't see a symbol, that implies multiplication. Okay? And by the way, there's another area that you could have found your triples. If up at that, if you kept a 10 and then where that 100 is, and you separate that 100 into 10 times 10, you would have had a triple right there with 10 times 10 times 10. As soon as you get a triple, you can just pull that off to the side when you're working with cube roots. If it's a 4th root, once you have a group of 4, you can just pull those off to the side. Or 5th roots, just pull those 5 off to the side. Okay? So, hey, I hope this made sense to you. Alright, if you want to see more examples like this or see what we're doing at Mirrorverse Education, then visit us at mirrorverseed.com. I thank you for watching. Hope you have a great day. Adios.